All right, let's talk statistics. Before we talk about statistics though, let me just make a note that Module 7 is all about ethics in research. You guys are responsible for reading that and taking notes on that on your own, okay? So with the Code of Ethics, you're going to be learning about things like debriefing, giving informed consent, what are the ethics of having tests done on animals versus humans. So do make sure that you have some of that in your notes. All right, let's talk statistics. For those of you guys who feel less confident doing mathematical types of equations, the good news is here that you're not going to ever have to run, you're not going to ever have to do some kind of statistical analysis like you don't need a formula, you don't need any specific program, but you do need to know the essence of what these types of statistics are. Okay, so the first kind of statistics that we're going to be talking about today are descriptive statistics. Descriptive statistics, say it in their name, they describe data. So it's giving you some information about your data set. We're going to talk about that in our next slide. The other type of statistics is inferential statistics. So inferential statistics studies a sample and it tries to make an inference about the larger population, okay? So we're going beyond describing in inferential statistics, and we're trying to predict future behaviors, results, outcomes, etc. All right, so what are descriptive statistics? Your book says that it's the numerical data used to measure and describe characteristics of a group. Okay, and that includes measures of central tendency, which we'll talk about in the next slide, and measures of variance or variation, which we'll get to in a little bit. Okay, probably one of the most well-noted forms of descriptive statistics that you're going to see in a psych book is the bar graph. Okay, and so the bar graph right here is just sort of a visual representation of data. Okay, here the bar graph is looking at people's favorite types of movies, okay? And so they're looking at these different genres and they're assessing. And so based on this bar graph, we can say that romance is the most popular type of movie in this population or this sample, and drama is the least favorite, okay? If we were going to apply that to our own school, it might be something like favorite types of movies for Carondelet sophomores, for instance. So the big thing to remember here about the bar graph is that it's categorical and the bars don't touch. So we see a lot of space in between the bars, and it's categorical, meaning that everything down here on the x-axis is not a number, it's a category, okay? So other things might be favorite fast food, favorite kinds of music, okay? So remembering here with the bar graph, we're doing categories and the data points don't touch. On the other hand, if you have a histogram, the bars do touch, and the x-axis is numerical, so we're actually measuring something with a number, okay? So this is one about trees, but let's say we were collecting average heights of De La Salle freshmen, for instance. We would use a histogram because it's a numerical measurement. It's not them picking their favorite thing, okay? So hopefully that makes sense. Please do work on your ability to look at a bar graph or a histogram and be able to see what that's saying. For instance, here with the least favorite type of movie being drama, you should be able to look at this bar graph and know that. Okay. All right. In a rare instance, you might be asked by being given a data point, some sets of data, you might be asked to actually create your own bar graph. So try to get comfortable with that and maybe practice yourself on that. Are you comfortable creating one of those? All right, so the measures of central tendency, I would say that I'm going to guess and going to hope that most of you guys have seen these sort of words before in some algebra math class. So the mean, the median, the mode, and the range, all four of these measures of central tendency are things that you should be able to calculate, okay? So the mean is our average. We add up all the numbers and divide it by the numbers in the set. The median is the middle score in the distribution. The mode is the most frequently occurring score in the distribution, and the range is the difference between the highest and lowest score in the distribution. And each one of these 4 measures of central tendency help to tell a story about the data. The book gives you the example of if Bill Gates walks into a cafe, right? Looking at the average income of each person in the cafe, right? The minute that Bill Gates walks into the cafe, the mean average income for the people in there goes up by billions of dollars, right? And so we know that not everybody in a cafe is a billionaire. We might actually want to look at the median, the middle score in the distribution, or we might want to look at the mode, which types of folks have the most frequently occurring salary. So it's important as we're looking at important data that we're actually looking at these different types of measures of central tendency, because each one tells a different story, and the more we have, the better equipped we are to be able to kind of describe what's going on. So just sticking with the example of Bill Gates walking into a cafe and looking at the average income of the people in it, Bill Gates walking into the cafe creates a skewed distribution. And that happens when a representation of scores lacks symmetry around the average value, okay? So let's say the average income of the people in this cafe is $100,000, and Bill Gates walks in and he's a multi-billionaire, okay? He's gonna skew the data because now the mean has now changed. The mean is now much larger because of one man who walked into the cafe, who walked into the data set. So it's important to remember that if we have a skewed distribution, there's probably some data points on either end of the extreme that are causing our mean to be farther away from the mode and the median, okay? Hopefully that makes sense. So just in thinking about another example, let's say that's not Bill Gates. Let's kind of go the other way here for this negative direction skew, okay? So let's say you're studying, you're doing a case study on LeBron James, a really amazing athlete, basketball player. You can argue with that about me later, but let's just like use this for an example, okay? And let's say within a particular series, he is doing fantastic and he is scoring an average of 50 points a game, okay? And then the team goes on the road and all of a sudden he has a few bad games where he scores maybe let's say only 5 or 10 points, okay? The data for LeBron James average points per game is now going to be skewed in a negative direction, okay? The mode and the median are probably still pretty high because by and large he has had these really high pointage games. However, a few points, a few bad games is going to bring the mean way down, okay? And so whether we're talking about LeBron James or Bill Gates or looking at test scores in a class, it's important to know that one really high or really low test or a couple in terms of a class can really skew your data, where you're not going to end up with a mean that really is close to the mode and the median. And that's why we need multiple types of descriptive statistics in order to make sense of the data.